First Spin. Welcome to First Spin, a show where I learn how to use the Parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of Roy and Whisker.
Hi.
Hello.
You guys are dorks.
I just got this like sinking sense of like I've been conscripted.
You have been. You drew the wrong number.
It's my lot in life.
Mm,
I'm
So,
laboring away in the salt mines of planet Addy.
right. Work. Monkey work. Okay, so we finished last week with looking at page 25 where we were talking about hub and cog access and such. And from page 25 to essentially the end of chapter 1, it pretty much just repeats a lot of the information that we've already gone through in the past few weeks because I asked very detailed questions. And so, if you want more details on each of these sections, then feel free to read those pages. They do go into quite a bit of detail. But we have made the decision to move on to chapter 2, spin language reference. And yeah, so are you guys okay with that? Or did you want
sounds
to
good to
go
me.
through the all the other stuff over again?
I've read that book, so I think I could turn in my report on time.
I see. Are you going to use a diorama?
Maybe. Be fun.
Mm.
With like parallax servos to make the little guys move around.
Hey, yeah, go for it. So, let's see. This chapter describes all elements of the propeller chip's spin language and is best used as a reference for individual elements of the spin language, etc. Spin language reference is divided into 3 sections. Structure of the propeller objects. Objects consist of spin code, optional assembly code, and data. An object spin code provides it with structure consisting of special purpose blocks. Name a few special purpose blocks.
Well, you have like your var block and your dat block and your obj block.
Ah, so in prop tool, those are the different colored sections.
Right, where you would do things like in your var block, you list out all your global variables, and in the obj block, you list out other objects that you want to include and use in this program. Right.
Gotcha. Gotcha. And is the only place you can find objects on the object exchange?
Some people post them on the forums. There's just sort of a random assortment of places, but most of the good objects that you want to use will be on Object Exchange.
And like I'll make variant versions of some of the popular objects to suit my own needs, and I'll just keep them in my own private repository.
And so objects are so in my projects I've used like playing wave file objects
Mm-hmm.
and I think that's actually the only one that really sticks out in mind. So I could theoretically either write it myself, and would I want to make it into an object, or could I just stick it into the code, like
What
generally?
there's it's kind of up to you. I mean, generally, if you're going to make an object that is something that might be reusable,
Mm-hmm.
then you'll want to put it into a separate file so that it can be used by multiple programs. And if it's something that might be useful to other people,
Mm-hmm.
then you might as well make an object and put it up on the Object Exchange.
Gotcha.
Um,
Now,
and of course, you probably want to go check to see if somebody hasn't already done that
right.
before you do it yourself, and maybe use theirs. And if it's not quite up to what you need, you could add on to it and then upload a new version to the Object Exchange.
Right. Now, I was taking a tentative look at the Propeller Board of Education site that they have, and that they're working on, and they have objects for turning on LEDs.
Uh huh.
Is that completely necessary?
Well, the Board of Education is designed around making it extremely simple to teach, in school to young kids.
Okay.
So they've made a set of objects. The education guys over at Parallax have made a set of objects that are more geared towards that. They hide a lot of the more advanced details inside of simple objects so that you can just write,
On.
turn lead on, turn lead off,
I
stuff like
see.
that. And you don't have to do things like dir A some number and out A some other number and have that turn an LED on, right?
I see. So theoretically, I could make my different heartbeats, different types of heartbeats objects.
Yep, if you wanted to.
Whoa. Okay. Gotcha.
One
Gotcha.
one other thing, just to since you brought up their Parallax site, is that another place to get objects is in the Parallax store for a lot of their sensors and products.
Mm-hmm.
They'll have on the page in the store where you can click to add it to your cart, they'll also have links to files that you can download that are things like the data sheet and an instruction manual, and sometimes there'll also be example object code that you can download and use to use that sensor. So that's
Gotcha.
also another good place to get object, propeller code to use with hardware.
Gotcha.
And there's also some people in the community that an item will be released in the general electronics hobbyist community, and you'll see it be put out there with a driver for Arduino or PIC or something like that. And someone in the Parallax community will go like, "Oh, we could use that thing on our much more awesome platform of the Propeller," and they'll go to the trouble of making a driver for it and handing it out to other people.
Mm-hmm.
Right.
Mm-hmm.
Like the RGB LED strip that you've been messing with
Right.
on our weekly video show, Tymkrs Television. Roy got a copy of it and created a little PASM driver for it.
Right.
Right. Then I actually went back to SparkFun and in the comments below the item on their store, added a link to my code so that anyone else using a propeller that happened to be there could see that it was already supported.
Gotcha.
Sharing is caring.
Now,
Exactly.
now, when would you make the decision to send it into the object exchange?
Um, it's just sort of your own personal choice. Generally you want it to be really good, clean code that does everything that you'd want it to do for whatever the thing is you're doing. So like if you're making an object to work with a particular piece of hardware, if you make it do all of the appropriate functions that you would want to do with that hardware, then it's probably a good idea to put it up there. I mean,
Mm-hmm.
some people are more prolific up there than others. They'll like go put lots and lots of objects up there because they like to share their code more, and some people
Sure.
don't put any up there.
Gotcha.
It's
Okay.
just there is sort of a unspoken standard, or maybe it's spoken. They want you to kind of put the code into a certain format so that it's consistent. Like it has documentation comments up at the top, and it'll have the MIT license because everything that goes in the object exchange has to be MIT licensed.
Mm-hmm.
You put that on the bottom, and there's some other things that they would like you to do to make them a little more standard object layouts so that they're easier for other people to use.
Mm-hmm.
Um, it's not super strict, um, but in general, if you follow the format better, then people will use it more, and people will be more apt to improve it and add on to it.
So
And
it's a better signal to noise ratio, in other words.
right, and I think that they're planning because they are working on revamping the object exchange, as far as I know, and I think they're planning on having sort of like the gold standard tag that they can tag onto objects, which they deem being good.
Mm-hmm.
And so if you make your object follow their form factor well, and it actually does what it's supposed to do, then you might get gold standard flagged, and then people will use your stuff more because it's flagged,
Sure.
that kind of thing. But I don't know exactly the details of that. That's something Parallax is in full control of. So
They
Sure.
should just call it the Roy standard instead of the gold standard.
well, the problem is that my standards are probably lower than theirs because they tend to want things to be even more dumbed down for just about anyone to be able to use it. And some of my stuff isn't totally up to that level as far as commenting every line and
Well, I did
things
try
like that.
reading the PASM and I got lost. So I was like, well, I'll
She
just
got to the
I'll just
DAT
wait for Roy
section.
to come and help me out here.
She was reading through the DAT section on that, and I don't think she really understood that she was looking at PASM code until I mentioned it. She's like, "Oh, that's PASM code." I'm like, "Yeah,
That's
just
why I don't understand any of it.
skip over that stuff."
Okay,
Yep.
cool. So, and then spin language reference is also divided into the categorical listing of the Propeller spin language. All elements, including operators and syntax symbols, are grouped by related function. It's a great way to quickly realize the breadth of the language and what features are available for specific uses. I'm sure we'll get to understanding that.
Yeah, I
This
guess.
grouping by related function, I'm not quite sure how
Yeah,
that.
well, they're basically there's just like all the spin functions that there are. That you've used a few of them, like the in and out, and I think you've even used the case thing now, and
Yep.
whatnot. They're basically just saying that some of the stuff is arranged in the manual here. Arranged based on being
Oh, I
related to each
see.
other.
Oh,
You know.
oh, okay, that
Yeah,
makes
and
sense.
I don't think we're really here to explain how to read a manual.
No. I'm just I didn't know if it's relevant to like actual programming, but okay, that makes sense.
Right.
And then the spin language elements. Most elements have their own dedicated subsection, alphabetically arranged. Ease searching for them. Wonderful,
Right.
wonderful.
Except for
Okay.
that
That's just
whole
like
part
all
in
the
the
different commands.
in the old manual where they put the big table that I always want to look at that has all like the colon equals and the question mark and all that stuff. It's got it listed in one table, but it's like stuck right in the middle of the language reference. Just doesn't
So
make any sense
I
to me.
actually have a question.
Well, that table actually, just to answer Whisker there,
Oh.
is in the quick start, the quick reference. So if you go into the prop tool and the help, and you'll bring up the quick reference PDF,
Cool.
there's like 2 or 3 pages, and one of the pages has all those operators that you were talking about listed.
Good to know.
That is good to know. I have a question. So
Mhm.
in the code, I often use blah 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 colon equals blah blah blah, right?
Is that a
Right.
new command?
Yes.
Blah blah blah. Does
Yes.
that
It's an
mean?
object. It's an object with the gold
Is that a
standard
variable name?
in the Addy exchange. So why colon equals instead of just equals?
um, it's I'm not exactly sure why Chip and Jeff chose to go that route. I think it might be just
Just to
uh,
differentiate between.
it might be more that everything that is an assignment has something before the equal sign. So like you can do plus equals, and that will do an addition and a sign, and
Oh,
you can do minus equals, and that will do a subtraction and a sign, and stuff like that. So I think they're just trying to say that colon equals is don't do anything but just assign. But all the other assignment things in spin have that, something before the equal sign.
so wait. Okay, so I know we'll probably get into this way later, but let's say we say x plus equals 5. That's
Right.
x plus 5, or is that x equals positive 5?
Now what that is x equals x plus 5.
Oh.
Yeah. We haven't talked about any of this kind of stuff with Addie
Oh.
yet, because I tend to when I show she asked me a question in more real time, not so much for showtime, but for real time, she'll ask me how to do something, and I'll always write it out in the long form. I'll write x colon equals x plus 5 and explain to her that that's how you increment it by 5,
Mm-hmm.
right? But there are a lot of ways to do it a
To
lot
shorten it.
shorter.
Right.
So then, okay, so say for like weight count, right? Could you
Mhm.
do x equals 2 million equals, or wait,
So
um
assignment is assigning to the
plus.
thing that's on the left.
Mm. So in
So
order, so say you know how normally I say x colon equals 2 million or whatever, 2 million plus CNT, right?
right.
So can I bring that 2 million before the equal sign? So x equals, or x.
No, No,
No.
because
Oh.
you have two operators there, or two operands, right? You have the 2 million and you have the CNT, and those both need to get added together and then assigned into X.
Ah.
In the case of the shorthand versions, like the plus equals, you're just taking a single thing, a number or a
Uh-huh.
result of some other operation, and you're just adding it to X. So if
Okay.
you have like some variable and you just want to add or subtract or multiply, then you can do that, the shorthand, plus equals, minus equals, times equals, divide
So
equals, all those.
so if it involves like operands, you can't do it in that shorthand style.
Right. If it has multiple operands being assigned to X,
I see.
or it just depends on the full math operation that you're trying to do in your expression.
Gotcha.
Right.
Interesting. Interesting. Okay. Okay. Here we have structure of propeller object slash spin. Each propeller object is a spin file that has an inherent structure consisting of up to 6 different special purpose blocks. Con, var, obj, pub, pry, and dat. So
Mhm.
con is the clock,
Well, con is short for
right?
constants,
Oh, I see.
and the constant block is where you define in like the clock mode and the clock frequency.
Mm-hmm.
You're setting up what those variables are going to be assigned to,
Mm-hmm.
right? So you can also do your own user constants that you can then use throughout the program in other places. Um, but in general, that's what that's for, right? You
Now,
just
when would you use your own constants?
um, it's something where like if you're going to use a number to equal like an operation, like say you want to assign one to on, right?
Okay, sure.
Then you could do that. You could say on equals 1 in the con block, and
And
then
one important thing about the con block and assignments is that up in the con block, you use just the equal sign. You
without the
don't
colon.
use the colon up there
Ah, why is that?
because you're not combining multiple things together or anything like that. It's always just this thing is equal to this literal thing, and it's not going to change.
I see.
Right. It's constant assignment area. I mean, they could have if they wanted to. Jeff and Chip just sort of decided that using the equals without the colon here made more sense.
Mm-hmm.
I didn't, some languages do that and some don't. It's just that they chose to do it
Preference.
that way, and
Sure,
that's just the way this language works.
sure, sure.
So anyway, in your con block, you can assign basically a human readable name to a number,
Okay,
right?
okay.
So that you can use that human readable name in your program and make your program easier to understand,
So instead
right?
of like some
Instead of
crazy
having a magic,
formula, then you
right?
just
Well,
say blah equals this
right.
constant.
So the simple version of, like I said, if you had on equals 1, then you could use on, in down in your code to equal turning on a bit,
Yeah,
right?
yeah.
So if you had out A15 equals on, right?
Ah, I see.
Instead of a 1.
Now, could you also use it as an integer? Like, can you
Um,
use it as both a determination of the status of a LED as well as an actual number involved in an equation?
oh yeah, yeah. It's literally what will happen is when the program gets compiled, everywhere where you put that word on, it
Mm-hmm.
will substitute in the number 1.
Cool.
And so you could use it for anything. Like you can have there's a whole list of constants here right on page 36 that are predefined
Right,
as equaling something.
right.
But you can add your own to equal other things. But I mean, you already use constants right now. Like when you did the clock mode equals xtol 1
Right,
plus PLL 16x.
right,
Well, xtol 1 is a constant that's
right,
already
right.
predefined to equal a special number.
Very cool.
And the same thing with
PLL
PL
16x.
16x and stuff
Right.
like that. That all gets automatically handled by the compiler to turn it into the appropriate value to assign into clock mode.
Gotcha.
And a couple of ones that are that you might use all the time are the constant of all capitals. True will give you a -1. False will give you a 0. POSX will give you the maximum positive integer. Negative NEGX will give you the maximum negative integer. And
Right.
capital P, capital I will, of course, give you a floating point pi.
Wait. Positive X,
POSX.
most positive integer in what?
Yeah, so it'll give you like
a-
2.1 billion positive, and then NEGX will give you -2.14 billion.
What determines the max or the
It's
min?
the
How many
32
bits
bit.
there
It's a
are.
Oh,
it's a 32-bit value, so it has a maximum positive and a maximum negative number
sure.
when
And
it's assigned in a.
it's signed, so the first bit is used for the sign
Gotcha.
rather
And then
than
all
a
the
number.
other.
If it were unsigned, it would go to 4 billion, but because it's signed, you're going from -2 billion to +2 billion, which is the same number of numbers. It's just that half of them fall above the 0, half of them fall under.
Okay.
Right.
Why don't we
But
actually,
anyway,
can we quickly go through the constant ones?
I just
We
went through
we know
5 of
most of
them.
them. So clock
right.
freq
Well, some of these keywords that are used in a constant block aren't constants per se. They're just they have special meaning in spin when they're in the constant block.
Okay.
So things like clock frequency and clock mode, there are constants that you assign values to,
Yeah.
and you can use them throughout your code, but they also have special meaning in that they actually set the clock register.
Well, clock
that
frequency
you,
is 1 second worth, right?
yeah, it's how many clock ticks go by in 1
One
second.
second, right. So clock freak is 1 second worth of clock ticks. Then clock mode is obviously which
It's a combination of the xtol 1, 2, 3 or X input
so the
and the
crystal.
PLL 1X through 16.
It's a bit
Right.
pattern that defines your whole clock mode, and there's a whole bunch of stuff that gets baked into it, but that's definitely outside of most spin people's
Well, no, I mean
what they'd be
that's
interested
no,
in.
I'm okay with just knowing it's the crystal plus the PLL
Yeah.
Right.
effect.
And that's what that
So,
is.
right. And
And
then
then
free?
free and stack are used to help you figure out the stack size needed for spin code, which you've
Right.
probably only dealt with a little bit because you've had to
Right.
do a cog new and you had to pass in a variable that was the stack going to that. So what a stack is, and I'll just do a quick little thing, is when you're running spin code and it goes through and calls another function and then comes back, it uses the stack to remember where to come back to.
Okay.
And so if you call into multiple functions, you'll need the stack to hold return addresses. The other thing that goes on the stack is any variables you put in a function that is local to just that function, which is a pub. You've done a pub already, so and if you've had a variable on the pub that was only available inside of that pub,
A local
then
variable?
a local variable, then
Mhm.
it's on the stack also. So you need to be able to, when you start a new cog and want it to run that program, you need to give it enough stack space to hold to hold all the things that might possibly go into the stack when it's running that spin code.
Okay, so
The
what
stack free and stack constants are an optional thing that you can put into the code that the compiler will help you figure out how much stack space is used. And it's sort of an advanced feature that most people don't use. I think there's actually an application note that explains how to do it.
hmm.
I could have made use of it, for example, on my podcast clock that I built, because it's constantly firing off new cogs, and I just basically had to give each stack enough space to make sure that there wouldn't be any problems. But I just guessed, I just threw a
Right.
bigger than necessary number. But using these, you could make it much smoother, much cleaner.
Well, how would you determine the exact amount of space you would need in each stack?
Well, the compiler can try to help you figure it out, and there's a procedure. Like I said, I've actually never gone through this because I usually just try it, and if my program doesn't work, I just increase the stack size a little bit until it works.
So it's kind of like giving RAM to a program.
Right. It's giving it a little bit more space to work with.
Okay.
And when you compile the main spin object, the stack is like all the other memory that you don't use.
Okay. And what's the maximum amount of? Oh,
Well, it
it
depends on how
depends
much
on how
memory
big your
you have.
program. Okay. Yeah. Yeah. Okay.
Right. Yeah. Because
And make
you
sure
have,
you give it enough, because man, oh man, if you've
yeah.
got that thing hooked to servos or motors or something and it doesn't have enough stack space, it acts funky.
So you would write underscore stack,
Well,
and then
like I said, I'm not sure the exact syntax of these because I've never actually used them.
you've never used
If
stack
we
before?
could go, we can. Well, I've never used these underbar stack and underbar
Oh.
free things before because, like I said, they're sort of an advanced feature.
Oh,
Although
sure.
we can go look in the manual and figure out what they do.
Cool.
Yeah, it says what page they're on. I don't know in the paper manual there, but in the newest version of the PDF, it's page
Okay,
202 and page 110 that these
so
live
the
on.
one that's underbar stack is if you know how much your program needs for stack space, you can specify it here, and then when you're compiling the program, if it determines that you won't have enough free memory to for that stack, it'll tell you,
I
right?
see.
So if you make a really big program, but it also needs a really big stack, then you can use that variable to tell it, hey, I need this much space, so tell me when I'm going to run out of stack space so I can adjust my program.
Gotcha. Ah, I see. So it's like a debug kind of.
Well, it's more like a hint to the compiler to say, hey, I happen to know that this program uses a lot of stack space.
Mm-hmm.
So here's the value that this is going to use, and it will make sure that there's that much space available
Mm-hmm.
for the stack, and it'll give you an error if there isn't.
And is it measured in like bits, bytes,
It's
longs?
number of longs reserved for stack space.
Gotcha. Cool. Okay.
Okay.
Yep.
And then the free is kind of related, but what it is it's not how much stack space is needed, but it's just you need this much space reserved because something is going to use it. Maybe not your spin code, but some other thing
Hmm.
is going to use it. Like if you use a PASM driver that uses a certain amount of memory in the hub, then you would use this free equals line and tell it, okay, well, some number of longs at the end of this program are reserved for the PASM code that I'm running.
Gotcha.
It's a more of an advanced feature that you probably won't ever use. Like I said, I've never actually used either of these
Okay.
uh, uh, commands. I just, I know they exist, but
Well, that works. Okay, and then X and freak is pretty much for
this,
for saying how many megahertz
We've
or
talked about
hertz.
this one before.
Yeah, for the clock
right.
stuff.
So you can use X in freak or you can use clock freak. You can't use them both. You can have one or the other. And generally, if you're using a crystal, you'll use X in freak instead of clock freak
Mm-hmm.
because you want to specify the crystal frequency,
Sure.
and then you set the clock mode to the appropriate modes, and the compiler will automatically set clock frequency for you.
And so you can
to
still
the-
use it in the rest of your
Right. You can still
code. You just don't need to put it in the con section.
right.
Okay.
You can't. It will actually give you an error if you put both in there.
I
I did
see.
have a crystal question that I thought of the other day. I'll just to have a second to answer. Roy, what happens if you were to do something like set your PLL to 1x and use a 80 megahertz crystal?
It will work.
Awesome.
But you have to specify the appropriate xtol value
Yep,
because the
obviously.
xtol value determines the capacitance that you use with the crystal and all that.
Good to
And
know.
actually, I believe with 80 megahertz, you actually have to use an oscillator
Hmm.
because I don't think it'll actually work with a crystal that goes 80 megahertz.
Hmm. Good to know.
But you can use like a 30 megahertz crystal and just specify 1x PLL, right, or 2x.
Right.
But if you're using an oscillator, you can actually go from DC to 80 megahertz
Mm-hmm.
without any PLL multiplying going on.
All
Gotcha.
Right.
right. We're just about out of time here, Eddie. You
Yeah.
got anything?
I had actually one last thing to say, but not about this stuff. It was a correction from I believe last week or 2 weeks ago. Jack Goudsmit mentioned that there is a difference in how the propeller reads 2 million cycles plus CNT versus CNT plus 2 million cycles in the wait count command, and that it's actually more accurate for us to write it as 2 million plus CNT. And there's apparently here in the manual, there's a bit that explains that. So I just wanted to make that clarification.
That would also explain why my clock is just a tiny, tiny bit laggy. You can't tell until it gets all the way up past like 60 minutes worth of counting.
Mm-hmm.
But once you get up that far, it gets a little bit off.
Gotcha.
We might be able to cover that when we find it in the manual.
Okay.
All right. That's
Sounds
all
good.
we have time for today. Thanks for listening, everyone. You can find this podcast every Tuesday at firstspin.tv.
Bye.
Bye.
See ya.